Welcome to the COLORCLOUD video tutorial.
In this tutorial you will learn how to check whether your printer needs to be profiled and how to create device link profiles and ICC output profiles. When you start the application, the web browser will automatically install two plugins. One is the Microsoft Silverlight plugin and the other is the measuring plugin, which is required for the communication between your measurement device and the web browser. When the plugins are installed, you can log in to the application by entering your username and password. The application consists of 3 steps, which are represented by the buttons at the top. Step 1, Evaluation, means measuring a color bar to check the status of your printer's color quality. If your printer needs to be reprofiled, then perform steps 2 and 3. In step 2, you specify the settings for the profiling process, and step 3 is the actual profiling process. The first thing to do is entering a process name. The process name identifies one particular evaluation and profiling process. You could also select an existing process name from this list in order to resume work done in a previous program session. All your settings, measurements and calculations would be loaded. Now select a print target. It defines the color bar, the target values to be matched and the tolerances. There are print targets for various standard printing conditions available, with tolerances for proof printing and the validation print process. Also select the measurement device. The application supports both the I1 and the I1IO table. Now click on Download Evaluation Wedge to download a PDF file with a color bar for the selected print target. Save this file to your disk and output it on your printer. Click Measure Evaluation Wedge to compare the colors of your printout with the target values defined by the printing standard. Click the Start button. The device calibrates itself. Place the media wedge on the I/O table. It does not matter how you place it. You may rotate it by 90 degrees or place it upside down. What does matter, however, is that you place the visor of the I1 on the 3 patches indicated on the screen. The patch on the top left, on the bottom left and on the bottom right. Press the button of the I1 device each time. Now the 3 strips of the color bar are scanned and measured. When the measurement is completed, the color patches appear on the screen. Click the Continue button. The measurement result is shown instantly. In our case, the evaluation has failed because the deviation values are out of tolerance. For average delta E, for example, the tolerance value is 3, but we have measured 5.42, and so on. Therefore, the red X icon appears, which tells us that our printer does no longer comply with the printing standard. We therefore need to create a new ICC device link profile or ICC output profile. This is what we will do now. Click the Continue button. This takes you to the second step, which allows you to specify all the settings and parameters for the color matching process that will finally create the profiles. The process name you have specified in the first step is automatically entered here and will be used as file name for your profiles. First of all, select the target ICC profile to define the press conditions to be matched on your printer. In our case, we select the default setting, which is ISO-coded version 2. The rendering intent depends on the size of your printer's color gamut. For toner-based printers, it is usually correct to select Absolute without paper white simulation. Use the Upload Target ICC Profile button if you want to match your printer to your company standard. You can then upload your own ICC profile. If you are going to create device link profiles, Then also select the RGB color space and RGB rendering intent in accordance with your expected RGB input data. From this list, select a test chart for your measurement device. In our case, we use an I1IO table and A3 size paper. The measurement mode defines the light you are using. M0 means measuring without any filter. M1 is relevant for the new generation of I1 devices and means measuring with light that stimulates optical brightness. That means light containing a defined amount of ultraviolet radiation. M2 means measuring with a UV cut filter. For proofing applications, we recommend to use M0 because this mode is defined by the validation print standard. For production environments that use paper with optical brightness, M2 is the correct choice. Now you have specified all parameters. Click Continue to proceed to step 3, which allows you to perform the iterative color matching process. The profiling test chart is now being calculated. When the PDF file has been generated, a colored circle appears to indicate that it is available for download. Click the Download Test Chart button to save the PDF file to your local disk and output the file on your printer. Before doing so, it is important to disable the color simulation profiles on your RIP or digital front end to make full use of the printer's color gamut. How to do this on a FreeFlow or Fiery print server will be covered in a separate video tutorial. Having printed the test chart, click Measure Test Chart to measure it using the I1IO table connected to your computer. You could also upload a measurement file if you have used another measurement device. Click the Start Measurement button to start the measuring process. The device calibrates itself. Place the test chart on the I1IO table and place the visor on the color patches indicated on the screen and press the button on the device each time. First on the patch on the top left, then on the bottom left, and finally on the bottom right. Now the test chart is scanned and measured automatically strip by strip. When the measurement is completed, the dialog closes and the color deviations are displayed in a table. In this first step of the iterative color matching process, we've achieved an average delta E of 5.8 and a maximum delta E of 14.9. Of course, these are rather high values. This is because we have printed without any color management to use the printer's full gamut. Now click on Start Optimization to reduce the color deviations. Based on the optimized color match, a new version of the profiling test chart will be calculated. This means the color match is applied to the test chart file. Now repeat the steps taken before. When the colored circle appears, click on Download Test Chart to save the color match test chart to your local disk. As before, print the test chart without using any color management. Now perform the second measurement. Click Measure Test Chart, click Start Measurement, wait until the device has calibrated itself and place the test chart on the I/O table. Place the visor on the 3 patches on the top left, bottom left and bottom right, and wait until the test chart has been scanned and measured. When the measurement is completed, the results are sent to the web server and displayed in the application. We can see that the delta values have improved. Delta E, maximum delta E and the standard deviation have become lower. If you like, you can further reduce the color deviations by starting yet another optimization. You can do this 2 or 3 times. We do not recommend to optimize more often. In most cases, this does not cause the delta values to become lower. They could even increase. We decide to optimize again, so we click Start Optimization. Now the color match is optimized again and applied to the test chart, which you can download as soon as the colored circle appears. Print the test chart without using any color management on your RIP and measure it in the same way as explained before. The results of this third measurement appear on the screen. Again, we have successfully reduced the color deviations. Average delta E has improved from 5.8 to 1.75 and maximum delta E from 14.9 to 5.77. The most important value is, of course, average delta E, which should be below 3. Maximum delta E should be below 8 if the validation print tolerances are applied. If you are happy with the result, then click the Calculate Profiles button. However, in case the deviations have become worse, then click the Undo Last Iteration button to remove the last measurement. We click Calculate Profiles because these are very good values. Now the profiles are being calculated. When this has finished, 3 colored circles appear to indicate that we can now download 3 types of different profiles: a CMYK device link, an RGB device link, and an optimized ICC output profile. Save the profiles to your local disk and import them into your RIP or digital front end. Make sure to change the color management setup so that these profiles will be applied. How to do this on a free-flow or Fiery print server will be covered in a separate video tutorial. Finally, you may want to check the quality of the new profiles. Simply go back to step 1 in our application. Download the evaluation wedge, print it, and measure it. Of course, with the new profiles, all deviation values are within the tolerance limits. This concludes our tutorial. You have learned how to check the color quality of your printer and how to create ICC device link and ICC output profiles. More details can be found in our online help system, which you can open by clicking the question mark.